Hi, this is Larry Signan. I'm just doing a quick video on my project 2 implementation. For my project, I used the TMP102 sensor from SparkFun. It uses its breakout board over here. You can see here is the datasheet. It uses I2C in order to send the temperature data it's read into the Arduino, and then the Arduino can process that and send it serially into our host, which is the PC. The TMP102 sensor, the actual sensor, if you read the datasheet, it's actually the chip itself. It's the chip body, and it will basically store the temperature in a temperature register. And when it does that temperature reading, it is in the digital value. It is a 12-bit value, but you can set it to 13-bit. But we don't need that much accuracy, or that much range, of temperature, so we'll just do 12 bits. And it has an accuracy of 0.625 per count or per bit. So each bit, when it's set to 1, it represents a temperature step of 0.625. And you can see here's the conversion. And the datasheet will go into how it does all its bells and whistles and how it does the temperature conversion. But for my project, to make it simple, since we're just implementing it rapidly, I just used the provided library by SparkFun, which takes care of all of the temperature conversions for me. And as I mentioned, I am doing the TMP102 uses I2C, so we're using the Arduino's wire.h library. So going into the code, we have the declaration of the TMP102 object, which is in this library called it as temp sensor. We have very important variables here, which you can read the comment as to what they do, and maybe pause the video, so because I don't want this video to run for too long. We have the function prototypes that we're using here, and then I'll go over them later. Here I have the setup. You can see we initialize the serial and the I2C connection. And then we initialize the temperature sensor with the library method called begin, and then we print some statements to confirm that we're done, and then we'll actually put the temperature sensor to sleep. This is so that we can save power, so we're not continuously getting the sensor data. We will only be getting the temperature sensor data each interrupt. So this is good because the TMP102 supports that. It calls it the one-shot conversion, where you can command it to take a temperature at the moment and then go back to sleep to save power. We initialize the timer interrupts, so you can see here in the implementation. I'm not going to go over too much about what this means because these are just the registers for initializing the timer 1 interrupts. But the idea with this is that the timer 1 interrupt is set for overflow. So whenever it reaches some overflow value, which is here, the 3035, it will trigger and call an interrupt. So you can read the comments here just to understand that better. But here, after we initialize the timer, in our main loop, all we have is this read sensor, which, as you can see, it's a boolean, and it's just set to true. If it's set to true, then we will perform the main loop will perform the reading of the temperature, and then we'll send that temperature serially, and then we will clear this boolean again back to false. And what you will see in the ISR is that the ISR is actually the one that will be setting this to true. So if we go over the ISR code, we configured it for the timer 1 overflow, which is OVF here. We disable the interrupts when we enter the ISR, and then we re-enable it. We reload the register for the timer 1 value, which is just set to 3035. And that will make it so that we will actually have an interrupt every 1 second, or a rate of 1 hertz. So here's the formula that you can take a look at. But yeah, so the value 3035 will indicate a 1 hertz interrupt rate with these other pre-configured settings. So we're executing this ISR every second, and every second that means that this variable called interrupt counter will be incremented. And then we have a conditional where if the interrupt counter modulo sensor read interval seconds, which is 10, so that's 10 seconds, so that means that we've had 10 different interrupts. So if we are at the 10th interrupt, which implies 10 seconds because the interrupts are 1 second each, if the modulo that is equal 0, that means that, yeah, we are at every 10 seconds. We will increment the sensor read interval count, and this is just As you can see, it says it counts the number of times the sensor has taken data. So this is just later for housekeeping and for printing out the time. And then the most important thing is that we will set the read sensor to true. And this will allow our main loop to perform its housekeeping task of reading the temperature and setting that temperature serially. Okay, so that's the ISR, pretty straightforward. The read temperature, as I mentioned earlier, it uses the one-shot function of the temperature of the TMP102 in order to read the temperature. So it configures the bit so that it'll read the temperature at this instance, and then it will be set to 0 once it's done converting that temperature and reading it. I mean, not converting, but once it's done reading that single temperature, it will be set to 1. So that's why we have this while not statement. And then here, the temperature can actually be, that was generated from the one shot, can be converted to Fahrenheit by calling this method called readTempF. And then after that, we will put the temp sensor back to sleep. Okay, and then I also have the send serial temperature, which, as the name implies, will send the time, which is the 10 seconds multiplied by the sensor read interval count, which again we saw earlier in the ISR. It's just incremented each time we read this temperature data, and it will print the temperature, and it will be written to a text file, which is in this Python script. You can take a look at this, but it's also described in my documentation. We're writing it to this text file, the temperature readings, I mean, and the time. So okay. Lastly, since I use the library, it's good to understand what's going on under the hood in that library. So I have the SparkFun TMP102 library open here. Okay. So as you can see, the main thing that we're doing to get the temperature is called readTempF, which is called the method readTempC, and it does the conversion. We take a look at readTempC. Basically, without going over the code, all it does is it takes the 12-bit value that was generated when we read the temperature. The 12-bit value is split into MSB and LSB. So the first element of this array is the MSB, most significant byte. The second element is the least significant byte. There's an if statement here, but this is only for 13 bits. So we're using 12 bits. So you can see here the digital temperature again is right here. It's just the MSB and the LSB. Okay, and then it'll just return the digital temperature multiplied by the accuracy of the sensor, which is 1 bit is equal to 0.0625 degrees Celsius. Okay, and that's pretty much it. And then the next upcoming section is the demonstration video. So thank you for watching. Hi, so this is my demonstration video for my project 2. So I have my setup over here in my freezer. Please excuse the mess. I have my temperature sensor connected to the Arduino via I2C. The Arduino will send the I2C temperature readings and the time via USB to my PC. And I actually have the script running right now. We're sort of in room temperature. It's starting to go down because we're already in the freezer. But see here, this is the Python script that you can read about in my documentation. What it does is basically just reads the temperature and outputs the temperature to the text file, which we can also see in the console because I'm also printing it out here. But let's go ahead and restart. So let's stop and rerun the program so that we can get a fresh set of temperature readings. So if let's go do it. Okay, there we go. So here you can see we're connected to the sensor. We're done. Anything from time and temperature and all the way down will be printed to the text file. So we have our first reading. We're already at 72 since we've had the sensor for a few seconds or so in the freezer. So I'm just going to keep it in there. I'm going to slightly close it, but not all the way. And we can just view a couple of the temperature readings every 10 seconds. And let's see it cranking down. We're already in the 60s. And let's just maybe do 2 more readings, so 20 seconds or so. And before I stop the video and continue on to the next part after 5 minutes. So now we're at 66 degrees Fahrenheit at 40 seconds. We're at 63 at 50. So yeah, see you in a bit. Okay, so this is part 2 of the demonstration video. We have reached approximately 5 minutes since we started taking the temperature readings. Just for verification, yep, this is where we were before. We started around 72, and now we are in the 30 degrees Fahrenheit or so. So now I'm just going to go ahead and take out my setup out of the freezer and put it back to room temperature level. So we should expect to see the temperature starting from the low 30s to hopefully within 5 minutes go back up to around high 70s and I think around low 80s. Oh, that's already, we already went up by 2 degrees in a span of 10 seconds since we're not in the freezer anymore. So let's just view a few readings again, and the final results will be in my Project 2 write-up documentation, so please feel free to take a look at the graph. But as expected, you can see the temperature is definitely starting to go up. We're already in the mid 40s after just about 20 to 30 seconds, and expect to be back to normal. So yeah, thank you for watching, and yep.